This video covers section 10.3 in your textbook, and we're going to be looking at two main concepts. The first of which is solving equations that are in quadratic form even though they themselves are not quadratic equations. And we'll use a simple U substitution to do that. And then we'll solve shared work problems, which requires us to be able to solve rational equations, something that we've already know how to do. But let's first deal with this U substitution business. We're talking about quadratic equations. Those are ones that have the form ax squared plus bx plus c equals 0. And since we're going to be doing this, using this idea of making a U substitution, our equations that we're going to end up solving are not going to be in terms of x variables, they're going to be in terms of U. So we'll be solving something that looks more like this. Note A, B, and C, those are just numbers. Those are the same numbers that we pulled out when we were doing the quadratic formula. The variable is the U squared, and the U is the variable. And so you can see this still has quadratic form. The AU squared plus BU plus C, that's still an equation that's in quadratic form. So the goal is to make our equation that we're given to look like this equation that's highlighted. And this is not that bad to do as long as we have the x to the fourth looking like U squared, and we have the x squared looking like U, and the numbers stay the same. Notice that this is now a quadratic equation that looks like the highlighted one over here. The difference is that in this problem U is U squared, or is x squared. U is x squared, and U squared becomes x to the fourth. Well, what we need then is we need to determine if our equation looks like this, what U substitution did we make? Well, I think it's pretty obvious that the U in this case has got to be x squared. Because if U is equal to x squared, then this 5U term looks like the 5x squared term. And then of course if we square both sides, if I were to square the U and square the x squared, then this becomes U squared equals x to the fourth. And notice that mixes with, or matches with, our substitution as well, because then this U squared right here would turn into x to the fourth. And this now is something that we know how to solve, because it's now a quadratic and it's factorable. We could factor it to U and U, and this would be U minus 9 and U plus 4. It's factorable. In which case U minus 9 equals 0 and U plus 4 equals 0, which means U equals 9 and U equals negative 4. Now, is that what we were trying to solve for? Were we trying to figure out what U is, or were we trying to figure out what x is? Our original equation was in terms of x, so we actually still need to figure out what x is. And I think the easiest way to do that is to go back to what our substitution was. Our substitution was that U was equal to x squared. So if I take my first answer, which was U equals 9, then that would be 9 equals x squared. And then my second one was U was equal to negative 4, which means this equation would turn into negative 4 equals x squared. Then how do we solve that? How do we solve for x? Well, hopefully you said the square root property, like we did in a couple of videos ago. Because if we took the square root of both sides, This one would give us that x is equal to plus or minus the square root of 9. And this one would give us that x was equal to plus or minus the square root of -4. Square root of 9 is 3. So that's x equals plus or minus 3. Then over here, square root of -4 is 2i. So this is plus or minus 2i. So all together here, how many answers do we have? We have 1, 2, 3, 4 answers. We have that x is equal to -2i, positive 2i, -3, and positive 3. We have 2 complex answers and 2 real answers for a total of 4 solutions. Okay, so hopefully that makes sense. Remember, the key here is that we first have to make our equation look like a quadratic by letting u be something in terms of x, which then turns our equation into u, which gives us answers for u, but we want to have answers in terms of x, so we plug those values back into our u substitution to find out what x is equal to. So let's take a look at another one. Remember, we want this to look like u squared plus u minus 6. Because then we can solve something like that. And the key is, again, to look at the middle term. Just like in the last one, we looked at the middle term to see what u was going to be. We looked at this guy, the 5x squared. And because we wanted that to be 5u, we let u equal x squared. Well, because we want this middle term to be u, we're going to let u equal square root x. And of course, if u equals square root x, then u squared equals the square root of x squared, which means u squared equals x. And that fits with our substitution as well, because right here our first term was x, which means it turns into u squared. The square root of x turns into u, and the minus 6 stays. And again, this is something that we can solve. We have u plus 3 and u minus 2, which gives us u plus 3 equals 0, u equals -3, or u minus 2 equals 0, u equals 2. Are we done? No, because we don't want our answers in terms of u, we want our answers in terms of x. So if we take this substitution, u equals the square root of x, then that gives us that -3 is equal to the square root of x, and 2 is equal to the square root of x. And we square both sides. We square this side and we get that -3 squared is equal to the square root of x squared, which gives us x equals 9. And then here we square this side. 2 squared equals the square root of x squared, which gives us x equals 4. And remember that whenever we have an equation that we're trying to solve that is a radical equation, we need to check to make sure that we don't get an extraneous solution. So let's now do our check. We need to do this anytime we have radical equations. So this original equation was radical, and so if we check, we end up with, if we check x equals 9, we end up with 9 plus square root 9 minus 6 equals 0, which gives us 9 plus 3 minus 6 equals 0. Is that true? No, because that gives us 6 equals 0, which is not true. So we would in fact throw that answer out. Let's check our other one, x equals 4. That would give us 4 plus square root of 4 minus 6 equals 0, which gives us 4 plus 2 minus 6 equals 0, which is 6 minus 6 equals 0, which does check out. So in this case, we only have one answer. We have x equals 4 as our only answer. You have to check for extraneous solutions anytime we are solving an equation that has a radical in it. You might make a little note here. Check for extraneous solutions. Alright, so that takes care of the first topic. The second topic is doing the work-related problems, shared work. And to be able to solve these, we're going to need to remember how to solve an equation, an irrational equation. You remember how to do that? You have to multiply by the least common denominator, which we should probably factor the bottom here. If we factor the bottom, we get x minus 4 and x plus 3, which happens to look like these other two denominators right here. So our least common denominator in this case is that most complicated one. It's the x minus 4 and the x plus 3. To get rid of this right-handed denominator, we need to multiply by x minus 4 and x plus 3. And the rule with any equation, if you multiply one piece by something, you have to multiply everything by that something. And then all our denominators cancel when we multiply. You've done this before. I just wanted to remind you what it looks like. Let's now take a look at a application problem. So these are the shared work problems, also called work rate problems. And they have to do with what happens when you solve a problem that has two different things sharing work. When you have maybe one person that can paint a house and another person that can paint a house, and how much faster the job happens when the two people work together. It has to do with that sort of thing. So this first example has to do with a pipe. It says a small pipe takes 40 minutes longer than a large pipe to fill a tank. If both pipes are working together, they can fill the tank in 75 minutes. How long does it take the small pipe alone to fill the tank? And the idea here, the idea that we're going to work with in this problem, is the idea of what a rate is. How do you calculate a rate? A rate is how fast you can do something. And my example I always like to give here is, if it takes me 5 hours total to paint a room, 5 hours total to paint a room, how much of the room has been painted in 1 hour? If it takes 5 hours total to paint a room, how much of the room has been painted in 1 hour? Well, each hour, a fifth of the room would be painted. So the answer to this question is 1/5. And that's how we find a rate, especially for these type of problems. The person that's doing this painting job can paint 1/5 of the room per hour. That's a rate. So we're going to define rate to be equal to 1 over the total time. And so the way they usually work out is you take the rate of the first person or pipe or whatever, and you add it to the rate at which the second pipe or person can do the job, and you get a combined rate. And there's two rates working together, can be added together to get a combined rate. And so let's see how we can apply this with the problem in the example. It says a small pipe takes 40 minutes longer than a large pipe to fill a tank. If both pipes working together can fill the tank in 75 minutes, how long will it take the small pipe to fill the tank? So the idea here is going to be the rate of the small pipe plus the rate of the large pipe equals the combined rate. And remember, rates are always this form. They're always 1 over the total time. And we don't know the total time for each of these individually. We do know, though, that when the pipes are both on and working together, that the total time is 75 minutes. So the rate then would be 1/75th per minute. And that these other rates are always also going to be 1 over something. So the question comes, since we don't know either one, how are we going to use one variable to define both unknowns? Well, we should probably let x be the variable that we're solving for. So when this problem, when it says how long does it take the small pipe to fill the tank, we're looking for the time of the small pipe. So I would think it would be best to let x be here. And since the smaller pipe takes 40 minutes longer by itself, then that means the larger pipe's time is x, not plus 40, but x minus 40. It's 40 minutes less time than the small pipe. And so this is our equation. It's 1 over time plus 1 over time equals 1 over total time. And we now know how to solve something like this. We want to get rid of the denominator. And our LCD for this problem is going to have to include all three denominators. It's going to need a 75, and it's going to need an x, and it's going to need an x minus 40. And because we need all three different denominators to get rid of these three different denominators. And so I'm going to multiply by 75x times x minus 4, 75x times x minus 4, and 75x times x minus 4. And then we're going to go about canceling what we can cancel. So in the first term, the x's cancel, and then the x minus 40's cancel. That should be, just notice that should be an x minus 40. So in the second term, the x minus 40's cancel, and then the last one, the 75's cancel. And so we multiply, we have what's left. In this first term, we have a 75 and an x minus 40. In the second term, we have a 75x. And then in the last one, we have an x times x minus 40. Okay. And we want to distribute, so we have 75x minus 75 times 40, which is what? $75 times 40 is 3,000 plus 75x equals x squared minus 40x. And now we say, it's a quadratic, so we got to get everything on one side. And we know that the left-hand side becomes 150x minus 3,000. So I want to subtract 150. And add 3,000. Which gives us x squared minus 190x plus 3,000. I already have is equal to 0. Okay, and so that It could be factorable, but it's such a big number, it's probably not likely that it is, or if it is, it's probably a lot more work than is going to be worth it. So this would probably be a good example where we solve using what method? Hopefully you said the quadratic equation, because quadratic equations always work. So this would be x equals negative b, so positive 190 minus the square root of negative 190 squared minus 4 times 1 times 3000 all over 2 times 1, which is 190 plus or minus 100 minus 12,000 over 2, which is 190 plus or minus square root of 24,100, which is 190 plus or minus about 155.2 over 2. Which really gives me two answers. It gives me the first one if we add them. So if we take 190 plus 155.2, divide that by 2, we get about 172.6 minutes. And then the other one we subtract is 190 minus 155.2 divided by 2, which equals about 17.4. Now, one of those is not reasonable because my large pipe time has to be 40 minutes less than the small pipe. So how can I be 40 minutes less than 17.4? It's not possible. That answer is not logical. But then and how can the 17.4, the time of the larger pipe, be, or the smaller pipe, be less than the total time of 75 minutes? Because that should be faster. So the more reasonable answer should be this 172.6 minutes. That's the time it takes for the smaller pipe to fill the tank all by itself. Alright? So there's a shared work example. Let's go ahead and look at one more of these. It says, working alone, Gabe can clean the gymnasium floor in 15 minutes less time than it takes Rob. If both janitors work together, it takes them 45 minutes to clean the gymnasium floor. How long does it take Gabe, working alone, to clean the gymnasium floor? Round to the nearest tenth of a minute. So let's go ahead and read this one. Working alone, Gabe can clean the gymnasium floor in 15 minutes less time than it takes Rob. If both janitors work together, it takes them 45 minutes to clean the floor. How long does it take Gabe, working alone, to clean the gymnasium floor? And so we're going to take, just like the last one, we're going to take the rate of Gabe. We're going to add that to the rate of Rob, which should give us the rate together with both of them working. Remember, this looks like 1 over some time plus 1 over time equals 1 over time. And I want you to just go ahead and think about this for a second. Pause the video and ask yourself, what goes in those denominators? Okay, so you took some time to think about it. I hope you were able to come up with something. Notice that it says here in the problem that it takes them 45 minutes to clean the gymnasium when they work together. When they work together, it takes them 45 minutes. So that's the time for the together, when they're working together. So this is going to be 1 over 45. And then we want to find how long it takes overall. It takes Gabe. So we want Gabe to be time x. And since Gabe can do it in 15 minutes less time than it takes Rob, Rob's the slower person, then Rob's time is going to be x plus 50. So again, we should be able to solve this problem. What is the LCD? Pause the video for a second and write down what do you think the LCD is going to be. Okay, I hope you took the time to pause the video and write down what the LCD is. I think that the LCD in this case, again, should include all three denominators. It needs the 45, it needs the x, and it needs the x plus 50. And so what are we going to do? We're going to multiply everything in this equation by that LCD. And I'm not going to finish this problem. I will give you the answer, though. I want you to go ahead and try it on your own. So the answer is it takes Gabe 71.5 minutes to clean the gym floor by himself. You should be able to get that answer. Alright, thanks for your time. We'll see you in class.